So we've talked about generally the fact that it seems kind of weird that I would know the population standard deviation, but not know the population mean. That should seem kind of strange. That probably realistically wouldn't happen very often. The only time it would happen is like we're using an old standard deviation from a past sample. So like something that happens annually, we might estimate by using the population parameter, population standard deviation from last year. So many times sigma is not known. So we have to estimate the standard deviation. Yours actually says stuff on here, right? Standard deviation of x bar by, okay, by s over square root n. So it was sigma over square root n. And I'm just writing stuff on here so we can talk about it. It was this. We're still going to have an n. We don't have this. So now we're going to estimate it using that. So we're estimating what it should be. So there's going to be a little bit of error. So it's going to be off by a little bit. This is called standard error. So like this is the standard deviation of the same plane distribution. This is our standard error, which is like the standard deviation that accounts for error because we're estimating a parameter. And because we're estimating a parameter, we have to deal with that error. And when we deal with that error, we use a t distribution instead of a z distribution. So if you'll flip on the back of your paper where there's nothing on there. And just draw a curve that looks like a z curve. Now, if you don't have another color, which is fine, use like dashes. That is what a t looks like in relation to a z. But a t distribution to a z distribution, it doesn't matter if we're dealing with means, we're dealing with proportions, what our numbers are. Our z distribution follows that black curve every single time exactly the same way it is. A t distribution changes with every single different n. So as your sample size increases, this gets lower and this gets higher. So as your sample size increases, it gets closer to the z here, which means the tails get lower. It gets closer to z here, which means the middle gets higher. Yes, as n, it's as n increases. And you don't need to draw this, but so I'm drawing one curve to show all of them. If I had to draw multiples on here, and I said, I need to know which one is a t with n equals 4 versus the one with t of n equals 12, would n equals 4 be the blue one or the red one? Because as your sample size gets bigger, it gets closer and closer to the z. Like I would expect you to, if I asked you this question this way and said, now draw it and label it, I expect you to draw this if I just tell you this. Not that it's perfect. I want to see the red is higher here than the blue, the red is lower here than the blue, and they get closer to the black, but don't actually cross black. Or don't actually get like lower than black here or higher than black here. So basically, if I asked you to draw these, you can do that. Probably the reason why I said that 4 times in a row. Let's go ahead and leave it on the back right now. So similarities and differences. I don't care where you write this. A z distribution is called a standard normal. Sometimes I forget to mention that, but why should this make sense? The word standard. What kind of z value? What are z values? They are standardized values. The whole point of a z-score is to standardize. So it is the normal curve using the standard values. So similarities and differences between z and t. What are things that are similar about the two curves? We just drew them, so you should be able to tell me some things that are the same. Which I could say that a couple different ways. They're bell-shaped. What else? What are some other words that we usually use at the same time we use bell-shaped? Symmetrical. Unimodal. I don't know what that was. We always relate. I don't think that y'all come up with this one on your own, but you do know this because we use it all the time. Relate the curve to numbers. What do I know about the whole curve? The area under it is what? Some of you are going to be like, God, I didn't even know that. But why should everybody know this? Because if I say, how do we figure out what we don't want, what do? Subtract it from 1, so 1 is the whole thing. So you actually use that, whether you're thinking about it that way or not. Based off of what I just drew, I want to talk about 2 of the differences just in the way I drew them. Where is somewhere that t is different than z?
The shape changes.
Shape changes. I'm just going to write changes. It's not technically the shape, it's still. I'm going to say changes for t using degrees of freedom and Z stays the same. What about looking at it? What else can you tell me is different? Where, like physically, where is Z different than T?
That's the middle one. And the side.
Okay, so in the middle, tell me the differences.
T will be below.
T is what?
It's below C.
And then where else? What?
Yeah, it's above C and it's
So there's more area in the tail of a T distribution than in a Z distribution. If I'm talking about it like something happening, more area in the tails means what? So let's say we're talking about test grades. Let's say the test averages 80. What does that mean if there's more area in the tails?
more variation between sections.
There's more variation, so more people would be farther away. More likely that people are farther away than the others. More variation was correct. And then I don't really like putting it as a similarity or a difference, but as N increases, what? So we already talked about this N increases, like we showed how it works here with the shorter and taller part. But from Friday, the one thing we said is as N increases, what?
It's more like Z.
What does T do? Closer to what? The bigger your sample size, the closer your T curve gets to Z. And why is that helpful with the chart itself? Because what value do we have on that chart? Infinity, and the values for the line where N is infinity are actually our
C value.
Z values. All right, so let's go through some really quick and make sure we know how to use our chart. I went through some on Friday. The ones on here aren't necessarily going to be ones that we use right now, but I want to make sure that you know how to use the T-chart. So I talked about on Friday at the bottom, it says confidence interval or confidence level. Well, that's where we are right now, so that's what we're going to want to use. But if I were to draw like something like a 90% confidence level or confidence interval, I would have 90% between here and here. So how much would I have at each tail? Well, what does that thing at the top say that doesn't say confidence interval or confidence level? It says what instead? Like we could read it along the bottom and read confidence level, or we could read it along the top and read. So this is your tail probability is the way it's asking it. So when it says a probability of 0.05 to the right, well, that's the same thing as saying a 90% confidence interval. So how do you find degrees of freedom? Let's just review. Now this one, it actually gives you degrees of freedom, so do I need to do that? No, because just make sure you know how to read the chart. So you go on the left side down to degrees of freedom of 5. You go under right tail a tail probability of 0.05, and you get what T value? So I'm going to go through these pretty quick, make sure that you're following along. If you don't know why it is what it is, then turn to somebody else and ask them. a t-distribution with 21 degrees of freedom. Now, if it says it has a probability of 0.99 to the right or to the left, am I going to be looking for a tail probability of 0.99? No, because if 99% is to the left, how much is to the right? 0.01. So I would look at it that way. And you get do C through G really quick and just make sure we know how to find our t values, like maybe a minute. And so C doesn't give you degrees of freedom, it gives you what instead? N, so you have to do N minus 1. And I wouldn't expect you to write all that out. I'm just doing that for right now. Like I would expect you to experience degrees of freedom at 14. And I mentioned this a little bit. I mentioned it with Z. Why do I put the star there sometimes with the T? How many do we have to find a confidence interval? You have a left side and a right side. You have positive, negative. So instead of writing positive, negative inside of an interval that's using positive, negative, I just do star saying that like we're doing it to the left and the right. Basically absolute value. Oh, what do you get for C?
Two point.
Yeah, I think you looked at one decimal over 2 point what?
1.1.
What do you get for D? 0.6 what? E. F. And so like these are confidence intervals, so I would be more likely to put a star there because it's left side or right side. F would be 2.045, and then G would be questions with any of those? All right, I'm gonna do one that's not on there. So what is my degrees of freedom? 62. Why is that an issue? 62 is not on there. So I want to be as correct as I can be conservatively. So should I go up to 80 or should I stay at 60? So if one of them is not on there, you go to the highest one that is on here that's not above it. So like the highest thing below. So if I had something like, even if it were 79 as my sample size, I would still use degrees of freedom of 60 because I need to be degrees of freedom that's less than that's on here. It says that on your sheet in front of you, which is like right where I think that last one was. So it should say something like, when your degrees of freedom does not appear in the table, use the greatest degrees of freedom available that is less than your desired degrees of freedom. You want to be as correct as possible, but without over. Okay, let's flip back to the back. This next quiz, there's a lot of like fill in the blank wording stuff, like concepts that are on this one, like similarities and differences, like talk about the different graphs between each other, more so than we usually have. Now, some of this might seem contradicting right now. We'll talk about ways to change them. If I told you to draw a graph in chapter 7 where we wanted it, like we had one on our test review that was like this, it was like, which one's the best one? We want ones that are what? Like we want our distribution to be what? We want it to be centered. We want low variability. Well, what are we talking about vocab this chapter that's variability? What talks about how much I go each way? Margin of error. So ideally we want a low margin of error. And the other thing we get to pick is what's something we change problem that usually they give us, but I could change it for every single problem. Like I'm not going to change my data, but I could change this number. The percent, the confidence level percent. So ideally, we want high confidence and low margin of error. Because if somebody comes in and says, I'm 50% sure about this, well, that's not very helpful. So that is something I'm going to be looking for in the quiz. So looking at 4-step, and we've already written this, but I want to make sure that we understand. So if I'm in plan, the first thing I have is method. What is my method going to say for a problem with a t-interval that we are currently doing? So my first decision is if it's what? 1 or 2. Well, we're still doing with 1. It is a sample. What's my next decision? Z or T. So right now it's going to be a T. Why is it a T? Because sigma what? And that's something you actually have to write there. So it is a 1 sample T. We're still doing a what? Before that. interval, we're doing confidence interval, and then we're still doing for means right now. What's our next thing in plan? What's our first condition? Random, does that change? No, we still want to say random. Normal, is that gonna change? Nope, stay the same. Independent, does that change? Nope. So, same conditions. So then the main thing that's gonna change for do is just symbols. So our equation for the confidence interval is gonna be what? What does it start with? X bar, that is our point estimate still. Plus minus, now it's gonna be what instead? T, and what's the other thing that changes? It's S over square root N instead of sigma over square root N. So realize that a lot of stuff I just went over with things that could be concept on the quiz will be on the quiz. Alright. Flip it back over to the front, yeah.
Why do you do so many?
Alright, so this plus minus is because we're going this way and this way. But technically when I draw this, I have a T that's here and a T that's here, which this one's positive and this one's negative. So that's like I'm going both directions, but this is also plus minus, and it just gets kind of chaotic. So like the star is saying we have one positive, one is negative. And some books use that and some books don't. Writing T by itself is fine, but eventually we start dealing with one-tailed stuff. So we're basically, the star is essentially saying that it's like that and not like that. But I'm not gonna like grade it to a star or something.
So it's like X bar plus or minus T, positive or negative.
Alright, so let's just talk through a problem all the way and not do it until tomorrow. So example 1. See if I have it pulled up, we can mark through it as we go. When 10 cars of a new model were tested for gas mileage, what's important there? Which N? The results showed a mean of, does yours say just win 10 cars? Okay. I might not have put random back in there. We're testing for gas mileage. The results showed a mean of 27.2, so this is my what? I'm gonna go ahead and just keep my units with it. I've got a standard deviation. Well, technically it can give me sigma or it can give me S. How do I know which one that is? And it's still talking about this group of 10 up here. So that's the easier way to do it, is like find your sample size and which things pertain to your sample. Well, this one still talks about the sample itself, so that's which one. And that's going to be the only difference about how you know it's a Z versus how you know it's a T. So this one would say something like, showed a mean of 27.2 miles per gallon and then have period. It is known that the population standard deviation is 1.8 miles per gallon, and that would make it a Z. But because this standard deviation is still talking about our sample, that's S. Because it's S, then we're using T. So that's the whole process of today versus before today. And then what is a 95% confidence interval? So that's my what? Confidence level. estimate of the gas mileage achieved by this model, assume population. So what is it that it tells us this. Means and proportions. Means and proportions. Means, should that be hard to figure out? No, it gives us standard deviation. It says the word mean. This one, I probably should add in the word random, which I probably will tomorrow, just so we don't have to deal with it. But you now see the difference between Z and T and when to find out. Going through the 4-step process is the exact same thing, other than we use a T instead of a Z in the process. Your quiz is right now written as Thursday, which I know this isn't ideal, but I can't tell you 100% right now. It technically could move to Friday, but I want to keep it Thursday. Definitely, whichever group isn't going to be here on Friday, it can be taken on Thursday, worst case scenario. So if we get to switching and deciding that we need until Friday to take it, you are more than welcome to stay after on Thursday and go ahead and get it taken care of, because we'll be done with material by then. I would have liked to have already done one 4-step before today, and then I'd feel definite about it being Thursday. We shouldn't be bad though.
4-step sheet.
Yes, that one.